Hi, everybody. Hear me okay? Okay, so I think we're going to get going. My name's Michael Weiss-Malik. Our guest today, Jonathan Kuniholm. I met him in, we think, 2007, as far as we can piece back together, at a SciFu conference. And he had some pretty cool tech that he was demoing on some open source robotic stuff related to prosthetics. And I was impressed enough that I said, hey, you should come and give a talk at Google sometime. And he took that to heart, and about 4 or 5 years later, emailed me and said, hey, you offered that talk at Google. Now would be a great time. So we're hosting him today. Jonathan is the president and founder of the Open Prosthetics Project. He's also a founder of Stumpworks, a startup that focuses on prosthetic technology. He's also a presidential appointee to the National Council on Disability, and the stuff he has to say is pretty cool. So please put your hands together and help me welcome John.
Thanks very much, Michael. Let me first just offer a disclaimer with respect to my government job. They encourage us to do this. That everything that I'm going to say today are my personal views and not reflective of any position of the government. So what I would like to talk about today is how we can design good design to solve problems that society has, for the most part, neglected. And I came across one of those problems personally after I lost my arm in 2005, and discovered that prosthetic arms were an orphan medical device. And in thinking a little bit more about why prosthetic arms lagged so far behind other technology that we use every day, I started to realize that prosthetic arms and orphan medical devices are part of a larger group of those problems that society has tended to neglect, which can be solved by something that we're beginning to call public interest design. And the question that I'd really like to talk about today, and I would actually like it to be the beginning of a discussion, because it's something that by no means I claim to have even begun to solve, is how can we marshal all of the tools at our disposal to trying to better solve those problems? Because very much now I believe that most of those problems are solved in kind of a haphazard way. Government-funded projects, philanthropy, side projects from industry. You name the way that people happen upon these issues and try to solve them. But in general, you can be sure that the resources and attention that we devote towards solving these underserved needs are going to lag far behind those problems, which are very obvious from every other standpoint, need solving, very profitable things. There was no question that cell phone technology was going to improve over the last 10 years, for example. So in the summer of 2005, I took leave from graduate school at Duke University, and I was deployed as a Marine to Iraq in Anbar province, and I was the platoon commander for an engineer platoon of about 50 Marines, and we were doing mostly what everybody was doing over there, which is sustainment and stability operations, patrolling, guarding convoys, that sort of thing. On New Year's Day of 2005, I was on a foot patrol that was ambushed by improvised explosive device, and the blast took off most of my forearm, and I found myself back in the States and learning about prosthetic arm technology. I managed to get myself back to school and get involved with a research project sponsored by DARPA called the Revolutionizing Prosthetics 2009 project. It was one of two that DARPA was funding, which is really the first serious prosthetic arm research effort that had occurred in the United States since um, there was a small one in the 70s, but really since World War II. Um, and the the goal was a really ambitious one. The goal was to create in 4 years, in 2007, an arm using commercially available technology that could go to market in that year in 2007, and then more ambitiously to create an arm that had more degrees of freedom, was fully neurally integrated, so nearly the same articulation as a native human arm, and full strength, and an incredibly ambitious project. What I think it's important to understand, there's been an enormous, and this picture is up here not to brag that I was on 60 Minutes, but to show the kind of attention that these projects got. For whatever reason, prosthetic arms tend to really capture the popular imagination. People love robotics. They love thinking about the barriers, the singularity and the barriers between man and machine disappearing, and it becomes a vehicle for all kinds of philosophical and science fiction interest. I think the takeaway about these projects, which is important to remember, is first of all that despite the amazing things that both of these research efforts accomplished, we still have not 10 years, more than 10 years since the war began in Afghanistan, actually pushing 15 now, still do not have any commercially available device that's resulted from any of this government-funded research. We're still waiting for the first one. It has remained, as always, just around the corner, and I'm told that we're waiting on FDA approval for the DECA RP07 project to receive FDA approval, and it has been in some clinical trials, but we still haven't seen a device. The other one is, I think that it's important to understand. It's my belief that we have a media bias. It's not a political conservative media bias, but it's one towards entertainment. And so the word bionic is used a lot. The words dexterous and manipulation are also used a lot, which have very specific meanings in robotics. And there are some caveats that I could give. You could call a trigger grip, for example, where one part of the hand is grasping a handle of a cordless drill and the finger is pulling the trigger. That tends toward sort of manipulation. It's at least a compound grasp, where one part of your hand is doing one thing and one doing another. Of course, the slide that I'm showing here right now gives you some insight into what the human hands are capable of. This pair of hands is doing a card trick where 4 cuts of the deck are being controlled by different parts of the 2 hands, and it's a dynamic movement. And so I guarantee you that there isn't a robotic hand of any kind that can do these card tricks right now. But based on the popular press presentation of all this, you would think that it can. You would think that these problems are solved. So while I think it's important to acknowledge the strides that were made by these research projects, it's also very important to understand that we are not there yet, and we do not have bionic people, and these hands are for the most part right now. I think that it would be fair to say, at least in terms of prosthetic control, that even these highly articulated hands are really only capable of grasping. And the difference between grasping and manipulation, I think you can use a Rubik's Cube to illustrate. Manipulation is a speed cuber solving a Rubik's Cube in a few minutes, and grasping is not dropping it. And grasping a Rubik's Cube is actually something that I can do with the hook that I wear when I do wear a prosthetic arm, which is the Dorrance 5X, named after the guy who patented it in 1912. And you can see that since then it's evolved a little bit. There's some rubber grip on the fingers, a cigarette notch, and I think it's called a pen notch now. But this remains, despite everything that's happened, the most used prosthetic terminal device in America. And were you to go to the Myoelectric Conference in New Brunswick in Canada this August, it would be a fair bet to make that the majority of amputees attending the conference, at least the ones who weren't paid to be there by a prosthetic company, would be wearing one of these devices and not any of the robotic prosthetic hands that are available. The other thing that's important to note about this is that there's another choice which actually beats all of them, which is the one that I'm wearing today, which is nothing. And about half of all arm amputees choose most times not to wear a prosthesis at all, and it's mostly because of weight and comfort and suspension, and I'm going to talk about that a little bit later. So now, why is all of that? This is by no means an attack on any of the folks who were generous enough to fund that project and try to make some progress. The real problem is that there simply isn't a market for these things. The market for powered arms is just barely noise compared to these other large markets. And even though the government has accomplished quite a bit in some of these research projects, what we call the valley of death, which is the bridge that one of these products must cross in order to get from the lab into becoming a clinical product, is really significant. And without a market to drive further funding, that gap, which is estimated by people in the industry to be something like 90% of the R&D remaining on a medical product once a proof of principle device is finished, there's just simply nowhere for those resources to come from and make it happen. And so, correspondingly, the amount of effort that's actually put into solving this problem is also very small compared to. I cherry-picked a few really large government-sponsored engineering projects, some of which have been compared to this DARPA prosthetics project. And this is all in 2006 dollars. The Manhattan Project comes in at over 20 billion. The Moon Race over 120 billion, and just the R&D for the Joint Strike Fighter at over 40 billion dollars. And so the 100 million, well, more than anybody had spent on prosthetic arms in half a century, the DARPA spend is basically just noise compared to this. So, and I would argue that the task that they set out to solve, rivals some of these in terms of the engineering effort required. I mean, it's a small project, and instead of a large one, but nevertheless, an enormous portion of our brains, for example, is devoted to the control of our hands in manipulation. I don't know if you all have ever seen, I don't have a slide of it here, but the homunculus that neural researchers use to represent, they take a human figure and adjust him proportionally based on the number of nerve endings in some studies of the brain. And so this little figure has gigantic lips, gigantic hands, and depending on whether you're looking at the censored version or not, gigantic genitalia, reflecting how much of our brains are devoted to these, to control these very parts of our body. And this is true both in terms of motor control and sensory control. It works both ways. And, as you can see from that slide of the card trick, feedback, sensory feedback is certainly a huge part of our hands being able to do what we do. So, what we have is a three-way market failure to solve this problem. Industry, government, and academia, all doing their parts, but all unable to solve this problem. And so, but of course, it's completely understandable, and that's why we call prosthetic arms an orphan device. The orphan drug law that was passed in 1983 defined patients in need of a drug as being medical orphans if their patient population was less than 250,000. So prosthetic arms in the United States are about, a couple years ago, 43,000. So fewer than 50,000 patients in the United States. So that's a sixth of the maximum threshold for being an orphan. Of course, the orphan drug law covers pharmaceuticals and not medical devices, so we don't have a companion regulation or law or anything that covers the creation of medical devices. And another peculiarity, of course, of that is how we pay for medical devices in the United States, and I will get to that a little bit later. So, as I mentioned before, all of these medical orphans, and the NIH, and this includes all of the orphan drug patient populations and others. The NIH lists something like 10,000 orphan conditions on its website, and because I happened to be interested in prosthetic arms, I searched for limb absence, arm absence, and so my particular orphan condition is actually not one of the ones that's listed on that site. So I would say that there are probably more. And so the question is, and this gets back to the graphs that I showed before, because there's obviously no market for it, it doesn't necessarily make sense. I wouldn't argue, for example, that it's a travesty that DARPA didn't invest $100 billion into solving this prosthetic arm problem, because the same could be said for any of these other orphans. We simply can't afford to do that. From a public health standpoint, it's just not an effective way to spend our resources. So nevertheless, feeling like this is a problem that we'd like for society to solve, and that it's not the only one, this is the question: how can we attack these problems and solve some of them? And it's clear that we probably need to think about them in a little bit different way than we are now. My friend Chuck Messer described this as using your geek powers for good. The Cooper Hewitt Design Museum, in referencing the 90% of the world that doesn't benefit from our consumer culture, they had a design exhibit several years ago called Design for the Other 90%, in reference to that. And there's another movement, here in the Bay Area, for example, you have a designer, an engineer named Ralph Hodgkiss, who makes a wheelchair. Whirlwind Wheelchair is their organization. They make appropriate technology wheelchairs that have larger balloon tires on the front to deal with uneven terrain and broken sidewalks that you're more likely to encounter, if there are sidewalks at all, in a lot of the developing world. And they have kind of a cool model where they try to set up factories as profitable businesses, a social enterprise, to manufacture this wheelchair design in the area where they might be used. And this, in contrast to sometimes what gets done in the wheelchair space, for example, is to send kind of rickety, sort of hospital wheelchair over to that environment where it lasts, like a lot of medical technology over there, about 10 minutes before it breaks, and then somebody has trouble finding a part to fix it, and it ends up getting junked. So there's whereas I'm arguing that prosthetic arm users in the United States are an underserved population. They're not disadvantaged, certainly, to the same degree that um, patients in the developing world are, but all of these patients are underserved in some way or another. So a good phrase that's been used to describe all of these problems and the design that we can use to try to attack them is public interest design in the public interest. And so really what I'd like to talk about is what are the ways besides, we'll start off with government-sponsored research because that's a lot of what's happening currently, but what is our whole quiver of tools that we might use to try to solve some of these problems? And yeah, sorry about that. So what are the collection of tools that we could use to try to better solve these problems? And I, like lots of people do, I think I'll probably come down on there being some combination of all of these that are necessary. But just to brush over them all, to begin with, government-sponsored research and commercialization, then DIY and the maker culture, potentially an orphan device law to serve as a companion to the orphan drug law that we've had in this country since 1983. And then what other regulatory or policy changes might be made, under our existing structure, but by program managers who fund, for example, some of this government-sponsored research. What things might they do to try to raise the impact of the research funding that they're currently giving out? And then secondly, what can we do in the private sector? Are there ways that folks in the private sector might be able to contribute in ways that don't impact their own bottom line, and they can potentially even have a win-win in serving these underserved folks? So to start off with, these are icons that represent the three major engineering research efforts that I showed the funding levels for: the moonshot, the atomic bomb, and the joint strike fighter. And it's certainly clear that there are some problems that government has to solve if they're going to get solved for us. Well, we do have SpaceX and a commercial space effort right now. It only exists because the government is choosing to create that capability, and the funding's coming from the government. So that's an example, actually, of sort of spreading this stuff around a little bit. But it was clear that sending a man to the moon, or building the bomb, however you feel about that having done, these were certainly projects that would never have happened had not one of the largest and wealthiest governments in the world decided that they were going to make it happen. And they happened because in at least two of these cases, the first two that I mentioned, the results were non-negotiable. We were going to get to the moon no matter how much it cost and how dangerous it was. And those who were in charge of the bomb viewed it as a response to an existential threat, and that failure was not an option. It's probably the government probably would have spent anything to achieve these ends. Now, a lot of times, some of these very programs and the other basic science research that the government does are cited as having intangible benefits that spin off that we would be without were it not for these other efforts. And so Tang, Teflon, and Velcro are three, and there's actually a myth-busting page on NASA's website that I have up there on the slide that says that, in fact, none of these three products were created by NASA or NASA-funded research, although the space program did take advantage of all of those. So they used Tang, Teflon, and Velcro, they did not create it. And I would argue that even if they had, building a bomb, sending somebody to the moon, or building a high-tech fighter jet are not the most efficient ways to create things like Tang, Teflon, and Velcro. So if what you want is a prosthetic arm, or to put somebody on the moon, or to build a fighter jet, that is what you do. And this is really comes down to a difference between engineering and basic science. So the point is that whatever efforts there are that are devoted to solving this problem, it really needs to be dedicated to solving the problem. And there needs to be some agreement on actually what the problem is. A significant component of at least the 4-year DARPA effort was based on the creation of a neural brain machine interface. And it is well, in the long term, it's certainly true that represents potentially a holy grail of prosthetic arms. It's not clear that is a necessary component of it, particularly given the state of the technology that most people are using every day. So I was at the time that I met Michael in 2007. We had a version of this hardware board that we were showing at Google SciFu. And this is Tim Hansen is now a postdoc at UCSF, and he created, when he was at the Nicolelis lab at Duke University, this signal processing board, which is capable of processing 16 EMG electromyogram signals from the surface of the skin that can detect muscle movements. And we designed it to have as many interfaces as possible, because our goal in this DIY space was to try to encourage experimentation and to try to benefit from the maker culture and the huge video game industry and hope that some of those resources and efforts and interests could rub off and make some improvements in prosthetic arms. What we learned is sort of the downside to DIY maker and open source culture was that these projects sometimes require, well, first, they can't be done completely without resources. And then secondly, there's an activation energy to any kind of collaborative effort, which if you don't cross, you have a lot of difficulty making anything happen. So this project is still alive. I looked, there were commits this week, but they're primarily, but all of those, as far as I'm aware, are coming from the 2 labs at UCSF and Duke that are using the hardware. So the schematics, all this is open source and GPL to the extent that it actually applies to all of it. The schematics are up there, all of the masks, the firmware for the board, everything is there. But as far as I'm aware, nobody has actually made one of these except for those 2 labs that are using it and active contributors. And Tim made a pretty complicated board. It's like 6 layers and has these tiny little vias and some O4 components on it. We made this thing in a toaster and had some horrible moments where somebody breathed on it, or and then you can't tell what any of those things are anymore, etc. So as far as I know, nobody from the larger DIY or maker culture has participated in this project. Now there's another part of the project. We have functioning pattern recognition software in MATLAB, which is not open source, and again, this is another barrier. In order to use the open source software that we have up there, you need to have access to something like $20,000 worth of MATLAB toolboxes, which you're only going to have if you're either in industry or you're in academia somewhere. So these again are some of the barriers, but Beyond that, this hasn't really had the impact that we really hoped that it would have when we started. Although I'm certainly proud that we tried, and it's a pretty cool piece of hardware. Here's another one. We had a little project on the Open Prosthetics project to recreate a prosthetic hook that was designed in the 20s, which has been out of production for something like 35 or 40 years. And most of the guys, and it is most of the guys who use this hook are, 80, 90 years old, and they live in the Midwest. There's, I think there are some um, demographic peculiarities about where this thing was prescribed or what people wanted to use it for. And I still get calls from people who find, very few, it's a trickle, who find this thing on the web and want one. And you can see here, this is a picture. Somebody, Bree Pettis put this in the Thingiverse, and there were a bunch of people. I got bunches of people who wanted to volunteer. They were offering to print as many of these things as they could on their first generation MakerBots, which is where I think this printed hook came from, to help the project. But unfortunately, even the latest generation MakerBot 2, which I have and really enjoy, it doesn't print in a material that's appropriate for actual use, at least in this design. This is made to be a metal hook, and you can see that the resolution is really not fantastic there. So, and what we discovered, that one in the lower right was printed using a selective laser sintering rapid prototyping process, and we had some tolerance problems with that one until the Service Bureau actually printed the thing out on a plate and then machined off the plate. The two jaws of the hook did not fit together, so we had something like more than 50 thousandths off on that thing. So, and I bring this up just to point out the limitations of some of these things, and you see this just to loop back for a moment to the breathless enthusiasm of the press for a lot of these things. I can't tell you the number of stories that I've seen in the last 2 years about a high school student who has 3D printed a prosthetic hand that is supposedly better than, you pick the price point of some commercially available prosthetic hand. And when there's really no scrutiny at all that's applied to these claims. Very often they're completely externally powered, like motors with strings, or maybe they're not even powered. In any case, nobody really closely examines the claim that some kid has bested a $40,000 prosthetic hand in his bedroom with a rep machine. And I consider myself to be a part of, and I fully embrace the maker culture. I think we also need to be very realistic about, what we've actually accomplished, and try not to run victory laps before we've actually done it. And I think that this probably is one of those cases. Now the happy ending to this story is that there actually is a prosthetic company called Toughwear. They re-engineered this and fixed some of the problems that we had actually identified with the original design. I think you can actually see it in that's an original hook from many decades ago up there, and you can see the places it's been welded. So this company fixed some of the problems and where these things were breaking, and I do believe that you can actually now purchase a version of this hook commercially again. So I consider that to be a success, even if we weren't the ones who did it. So lastly, and there is some bleed across here. Michael did reference the company that I've started. I also decided to back up a little bit and solve one of the problems about prosthetic arms that may be, in fact, the most vexing and least addressed, which is how we attach them to people's bodies. This is traditionally done with a hard carbon fiber or fiberglass socket, a rubber liner, and maybe a plastic socket there. And I would liken a lot of these designs to wearing wooden shoes and rubber socks. And it does pretty horrible things to your skin when there's moisture and friction involved. And heat, moisture, weight, and perceived weight is really related to all of these things, because people will tolerate hanging less off of your body when it doesn't really fit well. It feels like it's heavier if it's uncomfortable. So we decided that the the way to solve this was to go back to what prosthetic arms used to be like in the 40s, before the VA did all the research that created these composite sockets, and consider making prosthetic sockets more like shoes, like athletic shoes. Prosthetic sockets used to be made of leather, and I have been told by old guys who wear leather sockets that they're the most comfortable thing in the world, and they never wear anything else. But you can't find anybody to make one of these things now, because they're really labor intensive, and the VA actually did a whole bunch of research in the 40s trying to figure out how to make them not stink, which, because they're basically like shoes. So we now have a pending research proposal that we should hear from the Army and DARPA from any day now, to use current athletic shoe technology to try to make a flexible, variable compliance socket that's stiff in some places and flexible in others, breathable everywhere, that basically solves all of the same problems that your running shoes do. And this would address the number one reason that people abandon prosthetic arms. And that, by the way, actually includes, for example, one of the DARP arms that was tested in VA clinics among transradial patients like me. Comfort was actually one of the major reasons that I think about half of those patients said that they might not be interested in having one of those new arms. So if we solve that problem, then we could potentially make a lot of the other technology more effective, because we'll be better at attaching it to people's bodies. So that's what we're up to right now. An orphan device law. So at the time that the orphan drug law was passed in 1983, we had a bipartisan Congress, and I think that to imagine in the current legislative environment that we can get anything done may be over optimistic. Although perhaps in an ideal world, we would consider a law that could increase innovation and competition in this space. Now, for those of you who are unfamiliar with it, what the orphan drug law does is it extends exclusivity for a drug company who's developed a product, but who believes that the further investment necessary to actually bring a proven drug to market is not worth the investment, because their patent, the exclusivity available to them on their original patents is expired. Drug development is often a really long process, and it's a race against the sundown on the patents. Now, unfortunately, I'm not convinced that a similar model in these even much smaller orphan device spaces would actually do anything, because exclusivity in prosthetic arm patents is often abandoned when people decide to stop paying the maintenance on their prosthetic arm patents after 7 or 15 years. So they're leaving exclusivity on the table with regard to patents in this space already. So would extending it actually do anything? And I'm not convinced that it would. So, yeah.
There's such a long process for
Okay. So since we're not mic'd in the audience, the question is the approval process for medical devices, prosthetic arms specifically, similarly long as it is for drugs? That's sort of a complicated question, because it depends on which class of devices you're talking about. The FDA has 3 classes of medical devices, 1, 2, and 3. The DARPA neural sensing system would be a class 3 medical device, because it actually involves an internal implant. Most prosthetic devices right now are class 1, and they're not only class 1, they're class 1 exempt, which means that they're exempt from, there's something like 7 or 8 requirements for class 1 devices, and all but 3 of those are ignored for this group of class 1 exempt devices. So in fact, and this is something actually that there's been some, some of the folks who've been pursuing these new things have been assuming, and they may be right, that the FDA is seeking to regulate prosthetic arm stuff more rigorously than they have in the past. So even though you could bring, I mean, there are articulated myoelectric hands that have been brought to market in the last 5 years that that were brought to market. All you have to do basically is announce to the FDA that you're going to start selling these things and do it. And if you're going to test it, you just stamp it experimental, and you're good to go. But nobody wants to invest hundreds of millions of dollars in the creation of a device unless they are sure that they're going to get away with that. And the FDA had been making noises that they were going to try to bump up the classification of some of these things. And they also have a requirement for orthopedic devices, which is reasonable. It's based on, so a screw in an orthopedic implant is a class 1 device. It's a component of a class 3 device, which is the implant. And there was a bad failure in the 80s because of the changing of one of these class 1 devices. And so the FDA requires that each class 1 component be separately recertified with the class 3 system. And if somebody did something like that, for example, with say there's a bolt that can go through your skin into the bone. It's called osseointegration, a titanium bolt. And the bolt, of course, is a class 3 device because it goes inside the body. And if they required you to separately certify every prosthetic hand or foot that you attach to one of these systems, it would effectively mean that there wouldn't be any available because nobody would bother to do it. So so actually you bring up a really great point, which is that the FDA is a really important part of this, and some orphan device law, a hypothetical orphan device law or revisions of regulations that might really impact the space should try to remove some of those barriers that actually the FDA could potentially create in trying to better protect us. And there are humanitarian exemptions available, and so it's something that I think bears further consideration. So that leads into the next group of things, which are beyond new law. What about the interpretation of existing laws and regulations? The Bayh-Dole Act is the law from 1980 that governs the government-funded creation of intellectual property. And the part that most of us are familiar with if you've ever received a government grant is that the government has royalty-free, non-exclusive license to anything that they pay you to create. But then in order to encourage economic activity, anybody who creates the stuff has the permission to go off and license it, do whatever they want, exploit that intellectual property on their own, as long as they don't charge any royalties back to the government. In practice, I think some of this actually goes on because if they fund particularly weapon systems and stuff like that, it's not like they segment off what the intellectual property component of it is. It's not like anybody else can make some of these fighter jets or tanks or whatever. So the least popular provision of this law is what are called march-in rights, which means that if the government, there are 4 criteria that could be met where the government can come in and say, you are not making use of this intellectual property the way we intended you to, we're going to take it from you and give it to somebody else. And people, it has been exercised very few times, if ever, and it's a very unpopular, as you could imagine, provision with people who get a lot of government funding. How much time do we have? While this law exists, it is something that could be made use of that's on the books already, and so people, program managers could say, Okay, so it's been 15 years. You haven't you created a product where we're going to find somebody who will, because our goal is to bring something like this to market. And another one that I referenced earlier is the Center for Medicare and Medicaid Services. So all these devices and many medical devices are like this are reimbursed as durable medical equipment. Um, Canes, walkers, CPAP machines, and prosthetic devices. And the weirdness that this creates is that the whole cost of supporting the device for something like 5 years in between replacements has to be captured just in the provision of the product at the beginning of its life cycle, all of the appointments and everything. So a prosthetist needs to be able to function based on that. The other thing that's weird about this is that there's a perverse incentive, of course, to provide more of these products because, if you give somebody a myoelectric arm, it reimburses at $35,000. A body powered arm, maybe eight. And so the other thing is that the way that these reimbursement codes are created is that a company has to demonstrate efficacy, and then they petition CMS, and so that they have to basically outlay all of the R&D ahead before they know if they're going to get reimbursed. And there have been some recent cases where people get the wrong answer back from CMS and it kills the company. A good example is the iBot wheelchair, which everybody agrees is pretty impressive technology. That came back as being excluded to a very few pretty serious disabilities and not reimbursable at a rate that could sustain its manufacturer, and the company's closed its doors. And so it's actually up in the air what's going to happen to that technology. Hopefully, DECA, which is the creator of it, will figure something out. So one thing that I think people might do would be to create incentives in reimbursement codes. You could create a code for the performance of a particular device without knowing that it existed. So I could say, a 15 degree of freedom prosthetic hand and wrist that's capable of all of these performance criteria will reimburse at this rate. $150,000, whatever it is, and then a company would know ahead of time that they have a payday ahead of them if they're capable of meeting the criteria, and so it would be much more clear that this is possible. Then contract language. There's a bunch of open source and open architecture language that the Navy, for one, still has on kind of a dead website that's still up there, but it's sample program manager language to put in RFPs to ensure that you can get what you want out of them, and those are tools that could be used. And then lastly, the DARPA has made really good use of challenges and contests, and I think this sort of thing in partnership with industry might be very helpful. So I guess in some sense, my graphic here is somebody cutting red tape. Maybe I'm actually talking about creating some more in some cases, but you get the picture. So what about industry? And that's you guys here at Google. I think that Google has done some really creative things in terms of business model in creating great products that solve problems in ways that people hadn't before, and by focusing the business model in sort of unexpected parts of it. And so I think both Android, both the Android operating system and Gmail are good examples of that. And a recent acquisition of yours, the Nest company that makes these thermostats and the smoke detector, those are examples of products where people would have said the innovation is, these are commodities, you can't improve on this, it is what it is, everybody has to have one, and you're going to buy the $8.95 one instead of the $9.95 one because it just does whatever it needs to do. And I think the way that company was able to really pay attention to consumers, represents creative thinking, which is the way that probably everybody needs to attack challenging markets, and these ones that I've talked about are certainly some of them. So you guys have also been in the news recently for, by my count, something like 9, counting the drone company robotic acquisitions over the last year or so. And one of these is redwood robotics, which I think involves a part of a Willow Garage spinoff. And I looked a little bit. I'd never seen this hand picture before. It looks to me like a rendering. I don't know if it represents a real product. I think that it's interesting that in terms of a manipulation and terminal device, a hand acquisition that you guys chose to acquire redwood and not any of the companies that were involved in the DARPA prosthetic arms. There's an interesting companionship between robot teleoperation and prosthetics. Myron Diffler, who runs the Robonaut program for NASA at Johnson Space Center, said that when he thought about it, the prosthetic problem is basically a teleoperation problem. You just happen to be attached to the device you're trying to teleoperate. So in some sense, when you take away video latency to the moon or whatever, the prosthetic control problem might be in some sense easier. Although the way that these things are usually performed right now is with a sort of a haptic armature, and in the prosthetic case, obviously you're trying to control a limb that's absent, so you don't have access to those fingers to tell those digits where to move. Anyway, my point in bringing this up is that there is some great companionship to these problems, and in fact, while it is not clear right now who in America is ready to buy, for example, a personal assistance robot or some other things that one might imagine as products that could come out of companies like these down the road, there are prosthetic customers who can, according to the current reimbursement system, in some cases pay in excess of $100,000 for one of these devices. So it might be possible to create a synergy of interest where you're solving problems for the future of home and mass-produced robotics at the same time as you are serving prosthetic customers in the near term, even though they don't represent the huge revenue stream that we all would if everybody has a Jetsons style made in their home. This is a picture of my friend Kevin, who was born without both of his legs. I throw his picture up there because he is in some ways represents an orphan of an even smaller community than my own. Without any hip joints, when he was about 10 years old, they tried to put prosthetic legs on him, and they weren't really anything but another couple of extra crutches for him to sort of haul around. And he very quickly decided that he wanted no part of that, and he gets around on a skateboard. Now, that said, if you were to envision, and that's a way to stay active too, but if you were to envision a robotic prosthetic device that might help him, it could look something like, Boston Dynamics, I forget the name of the company that in Cambridge. They have the big dog walking bot and those others where they pretty famously kick them over in the video. A pair of those walking legs controlled like the Segway is by leaning, could do a pretty fair bit towards replacing legs. And so that's sort of another case where one of these robotics companies might hold in currently available technology the keys to making a change in somebody's life. And my hope in mentioning industry, and I think again none of these are mutually exclusive. I do believe that the only way that we are going to solve these extremely vexing problems to society is by throwing nearly everything that we have at it and seeing what sticks. And so really my purpose in talking to you today is to try. I want to start this conversation because it's pretty clear to me that there are some things that we could do better about how we're responding to these problems, and I'd very much like some help in figuring out how to do it. I used up more time than I had intended to, but if you all have any questions, I'd certainly like to try and answer them. So the question is, I mentioned that most arm amputees still use hooks, vice the more complicated electrical externally powered prostheses, and why. I think cost is part of it. The Affordable Care Act has changed some of that. Before January, a lot of people with medical insurance had lifetime caps of, in some cases, just more like $1,500 lifetime cap on prosthetic services, which isn't even enough to get a single prosthesis. And beyond the expansion of coverage, the removal of the lifetime caps and pre-existing conditions are huge for the prosthetic community. So to the extent that it is monetary, the Affordable Care Act should change some of that. Anecdotally, I don't think that there's any great data on this, but I think that a lot of common complaints about the myoelectric prostheses are latency, unintended movements, the speed with which the motors move, the weight, and then I think you hit on it. Function is probably the primary reason. The hook has been famously described in TED Talks as a rubber band and a hook on the end of a stick, but I believe that the bar is actually quite a bit higher than that. The Dorrance hook is really kind of a marvel of design. It's got a bunch of affordances kind of built into it. You can pick something up, use it as a hook, and then as a split hook, you can open it up and use the individual fingers for different things. The little thumb that has the cable on it, here, I'll put that back up. The little thumb that has the cable on it can be used to push things, and is the part of the device that you use to wedge a knife and a fork. Actually, that's a perfect example is eating with a knife and a fork. With cosmetic coverings on the myoelectric hands, they tend to be slippery, and it's hard to get a knife and a fork to sit securely in them. And this thing is designed to do exactly that. It's got a chisel tang in the middle, so you can stick a tool in there, or you can wedge either a knife or fork in between the fingers and over the thumb. So I think, function is a lot of it. Any other questions? Yeah. Yeah. So, well, first of all, it's selfish of me, right? That's my problem. So that's what I've just spent a lot of time thinking about. But there are other complications. So there are something like 50 times more leg amputees in America than arm amputees because of peripheral vascular disease secondary to diabetes. And that's the major cause of leg amputation. So there are more than 2 million leg amputees in America, and most of and it's an easier problem to solve too. When you're looking at Oscar Pistorius is a great example. The cheetah legs make somebody capable of running close to 10-second 100. Although knees are a problem, and Oscar Pistorius is a below knee amputee. But then among the powered devices, control engineers who work on legs have told me that it's possible to do reasonable approximations of gait with the individual components not even talking to each other, where they just respond to the external forces and they're capable of doing a pretty good job walking. And contrast that to an arm where just, I mean, forget the manipulation stuff. Just reach to grasp with a whole arm for somebody up to the shoulder level involves the coordination of all of the joints together. So I like to say that if you imagine, that these are legs, the arm problem has 5 of them on the end of a 6th, and they all have to dance together in order to do the most basic task that an arm has to do. Yeah, and so the economics are, I mean, the legs are a lot bigger business. So there is a real incentive. Although, there are some new leg companies that because of the high cost of additional degrees of freedom, there are some leg companies that are going to be in trouble if they don't get the reimbursements that they want on power to ankles, for example. And so in that sense, they share exactly the same problem. Anything else? Any questions from our remote rooms? All right. Well, listen. Thank you very much for taking the time to check it out. And I don't know if there's a way for me to post contact information or whatever, but if anybody's interested in further talking about this, please get with Michael Weiss-Malik, and he'll put you in touch with me. Thanks very much.